Our pentest starts off by researching our target and enumerating their network and human infrastructure. After profiling the network and choosing our targets, we decide to pick on their commercial web server, which has the HTTP and FTP services exposed to the internet. We do not know this yet, but this server has a back-end database which lives in an internal non-routable network. We'll quickly start with a port scan on the target machine. We'll target ports 21 and 80 respectively, just to verify that they're up and running. And once we've done that, let's start probing each port and try figuring out what type of service is hiding behind this port. So that's an HTTP server running Apache on Ubuntu. And let's quickly FTP to our FTP server. Now, after a bit of prodding, we realized that this server was running a ProFTP MySQL authentication mechanism. So we've just seen that we don't have anonymous access to this web server. But if we try and exploit the SQL vulnerability, the SQL injection vulnerability on this server, then we can actually bypass the authentication mechanism and log in. So this is a great starting point. We have unauthenticated access to the FTP server, but we quickly face a small problem. There are hundreds of FTP users defined in the database, each with his own home directory. We can upload and download files to our liking, but there's no visible path to code execution, unless we can find the FTP user that gets mapped to the HTTP route of the web server. A short piece of Python code can solve that by brute forcing the FTP user home directories and searching for the right user. The following script shows a simplified brute force attack. Essentially, we're logging in as each user in the system, and we simply print out the home directory of that user. So let's quickly run this script and see what happens. So in our testing environment, the first few users have nothing in their home directory, but user number 5, or user number 6 actually, has all these files mapped to his home directory, and these files look suspiciously similar to what you'd expect to find in a web root. So we assumed that this was the right user. This user was really mapped to the web root. Let's quickly check that by manually trying to log in as this user. And there you have it. So it looks like we really are in the web root. We start by uploading a reverse shell PHP file. This will essentially send us back a reverse shell to our attacking IP. Let's quickly do that. Trigger the reverse shell using wget. And we get our reverse shell. Notice that we're running with the permissions of the web server. We're not running as a privileged user. So now that we have initial access to our web server, let's start poking around the PHP code and see if we can somehow elevate our permissions or elevate our access to other servers. Now, considering this is a dynamic e-commerce web server, we should expect to at least find some credentials to a database server, where all the sensitive information is stored. And a quick peek at our access at our shell of the web server shows us that this machine is dual-homed. So after a bit of prodding, we found a configuration file which holds some interesting information. Let's take a quick look at that. The file is called configure.php, and amongst other things, it contains some interesting information For example, a MySQL server host. We can see that this is a non-routable IP address, a username and a password. So we take these credentials and we try logging in from the web server, from our compromised web server, to the internal non-routable database server with the credentials we find. And lo and behold, once we try to dump the database into our HTTP server, we dump it into a writable directory such as images, all the data just pours out. So this file, which was dumped from the internal database, is now on the external web server and should be accessible to us through our browser. Let's quickly try that. Great. So our evil plan works, and this also confirms that our credentials are valid to the remote SQL server. Looking back at the configuration file, a few things caught our attention. The first was that the database server was hosted on a different machine than the web server, inside a non-routable internal network. The second was the fact that the web application was accessing the database server using the root user, which at least suggests some degree of misconfiguration. So this vector just got bumped up in our priority list, and we decide to pursue it head-on. We will need to upload some files, so we quickly upload some utility PHP and HTML files, which will allow us to upload our malicious files to the web server. But these files are interesting in a way, as they won't be simply uploading files to the web server. The PHP script uploaded to the web server will actually take a binary file and load it into the remote SQL server using the credentials that we found earlier. So essentially we're going to be binary dumping information into the internal database server by using the HTTP server as a proxy. So we quickly upload a reverse shell, a compiled binary reverse shell, and a pre-compiled MySQL external function, a UDF library. Now this UDF library is evil in the fact that it can essentially introduce command execution into the MySQL server. And our evil plan is to dump the files from the database server to the MySQL file system. And this is interesting because essentially we're once again bypassing the fact that the internal database server is non-routable. So we quickly log into the MySQL server through our compromised Apache web server, once again using the credentials we found in the config file. And now that all the files are in place, the UDF files are in place, essentially we're going to be dumping the information, the binary files in the database to the local file system. So we just need to introduce the new schema for our UDF function. Once again, we'll quickly log into the SQL server as we've been kicked out. And once logged in, we'll use our specific database. We'll expand the schema to allow all these external functions. And now that everything is in place, we can simply execute the BD file, which is located in /temp. And this should be sending us a reverse shell, just as we run this command. Remember that this reverse shell is now coming from the internal non-routable MySQL server, and it's allowed to reach us as the firewall rules allow outgoing port 3306. So once we hit that command, once we hit that enter button, of course we need to get our netcat listener, we should be getting a shell from the internal MySQL server. And there we have it. We now have a reverse shell with root privileges, by the way, from the internal MySQL server. Let's quickly run another reverse shell, as this will aid us in our evil plan in the very near future. So we've got two reverse shells from our internal MySQL server. What we'd like to do now is do a bit of fancy tunneling in order to expand our influence in the network. And after a bit of prodding inside the internal network, we identified our prize machine. This was the internal corporate mail server. So let's quickly ping that puppy and see if it gives us a reply. Alright, so we get a reply. And what we want to do now is quickly run a very basic vulnerability scan against our mail server. And in order to do this, we'll be building a reverse SSH tunnel, which will redirect port 445 on the internal mail server to our attacking machine. So let's quickly build that tunnel and check that the tunnel was created entirely. We'll rename the console Windows session just so we don't get confused as tunnels keep on getting built. And a quick netstat should just verify that our tunnel is alive and well. Let's give that a try. And look at that. On port 445 we have a mysterious port listening on our attacking Linux machine. We can run nmap and use a utility script to verify a certain vulnerability on that machine. And this is essentially running through our tunnel. This is quite interesting the way this is working. And unbelievably, we find that this machine is vulnerable to MS-08067. This is the same vulnerability the Configure worm was exploiting a few months back. So once again, things look nice and easy. We have a classic, well-exploited vulnerability just waiting to be exploited. But once again, two nagging little issues. The first is that our prize mail server is located in the internal network, which is non-routable to the internet. The second niggling fact is that we must assume that the internal mail server, which is running Windows 2003 R2, has hardware dep enabled, which we will have to address as no NX bypassing exploits were published at the time. After many hours of pain, we managed to get a solid exploit working, which was able to bypass NX, and the plan was to send a bind shell payload to the mail server and then connect to that bind shell using another SSH tunnel. Let's take a quick look at how we implement this. Once again, let's rename this console window so we don't get confused by our tunneling. So this is the tunnel we will be using to get our bind shell. Let's quickly reorganize some windows here and take a peek at our custom exploit. Notice how this exploit once again will generate a bind shell on port 444, and this will be on the internal non-routable mail server. And everything is in place, so let's quickly fire our exploit against our local host, and again this will be tunneled to our victim mail server. And since our second tunnel is in place, let's quickly connect to it, and lo and behold, we're given a prompt which belongs to our internal non-routable mail server. So this is wonderful, because we can now easily add an administrative user to this server. And once that's done, we can attempt to create one last tunnel to the remote desktop port Let's quickly try that. We'll kill our old tunnel and recreate a new one. So once again, this tunnel will redirect port 3389 from the remote mail server to my attacking machine on port 3389. Let's quickly complete this tunnel and then try to access this port on our attacking machine. The quick netstat should show us that this port is indeed being tunneled correctly. Let's give that a try. And once again, there you go, port 3389 mapped to our attacking machine. So all that's left to do now is basically connect to that port, and the tunnel should take us to the remote mail server. And since we manually added an administrative user, all we need to do is log in with that user, and we have another case of game over. In this relatively simple scenario, we can see that there are often realistic difficulties which are not necessarily easy to overcome. You will often be required to use offensive and creative thinking during real-world penetration testing. Thanks for joining us. We hope you enjoyed this webcast.